Today we're going to take a look at section 8.2, which is Law of Sines, day 2. So yesterday we talked about a few things. We talked about the ambiguous case. So remember, a triangle could be ambiguous when we are given side, side, and angle. So two sides and an angle. If this is the case, there are three possibilities. One of the possibilities is that we can't form a triangle. So we took a look at this one yesterday where when we go to do sine, you're trying to find sine of a value that's bigger than 1 or possibly smaller than -1. So we know sine has to bounce between -1 and 1, so it's possible that no triangle can be formed. Okay, there's also a possibility that we can only get one triangle. And that occurs when in the second triangle, the angles that we find sum to more than 180 degrees. All right, and then the last one is it is possible that two triangles can be formed, and then we have to solve both triangles. All right, so why the ambiguous case? So let's talk about, basic trig. So I know that when I'm looking for an angle, I have to do sine inverse of the angle. And we know that angle is positive, and that's going to be equal to angle A, angle B, whatever we're looking for. So one of the possibilities is that that angle is in quadrant 1, right? So say that reference angle was 50 degrees. Well, we've got a small problem because remember, sine can be positive in two different places. It can be positive in quadrant 1 or quadrant 2. So if we use that reference angle, remember, we're going to take 180 and we're going to subtract that 50. So that gives me an angle of 130 degrees. Well, 130 degrees is a possible angle for a triangle, right? It has to add up to 180, so one of those angles could be 30 degrees. So realistically, it could be an angle in quadrant 1, or it could also give you a value in quadrant 2. So that's where that second triangle comes into play. And obviously, we'll take a greater look at that over the course of today's notes. So let's take a look at angle 1. Let's solve the triangle, and can it be ambiguous? So again, we've got side, side, and angle. So absolutely, this could be the ambiguous case because we have side, side, angle. So we do have to check for a second triangle. All right, so the nice thing is we're going to start this just like we did the last, or the examples yesterday. So this is side C, angle C, so we know this is side C. Angle A we don't know, but we do know that this is lowercase or side A. And then we've got angle B straight across from there is going to be side B. All right, so one of the ways we know we can use law of sines is if we have that full fraction. So I have angle C. I also have side C, so I do have that full fraction. All right, so let's look for angle A first. And again, the only reason I'm choosing angle A first is because it's first in the list. We could find angle B first as well. Okay, so we've got sine of A over side A, which in this case is 2. I don't know enough about B. I don't know anything about B, so we're going to use C, which is our full fraction, and it's going to be sine of 25 over 1. Okay, so just like we did yesterday, we can go ahead and cross multiply. So that gives me sine of A times 1, or just sine of A is equal to 2 times sine of 25. So when I plug that into my calculator, I have to do 2 times sine of 25. That gives me 0.84. So I know sine of A is approximately equal to 0.845, and it keeps going on forever. So I'm going to keep that number in my calculator. And again, since we are looking for the angle, we have to use inverse sine. So I'm going to go second sine, and then second, and then the negative sign drops down that answer. And that gives me 57.7 degrees. So that gives me angle A is approximately equal to 57.7 degrees. So there is angle A, 57.7 degrees. Okay, so here's the problem though. Sine is positive 8,4 here at 57.7 degrees. I also know sine is positive here, and again, my reference angle is going to be the same, that 57.7. So what I have to do is I have to look to see if there's a second triangle that can be formed. To find, we're going to call this A prime. So the first triangle is just going to be A, B, and C. The second triangle I'm going to call A with a little apostrophe, A prime, B prime, angle B prime, and then the side B prime. It's just another way to reference a different triangle, but we're going to keep the A, B, and C in the same spot. I have to just do 180 minus 57.7 So angle A would be approximately 122.3 degrees. Okay, so in the triangle up above, I'm going to go ahead and put in 57.7. And in the triangle down below, I'm going to go ahead and put in 122.3 degrees. Okay, so we've got to see, can this be a actual triangle? Okay, so far in the triangle up above, we're good. We've got 57.7 and 25. That does not add up to anything over 180. And down here, if this is 122 and that's 25, that's 147.3. That's under 180 as well. So in this situation, we are going to get two triangles. So the downside with that is now we have to solve both triangles. So we have to find all the angles and all the sides. So let's take a look at triangle 1, and we'll solve triangle 1 first. Okay, so to find angle B, nice thing is we know two of the angles already. So to find angle B, I just have to do 180 minus 57.7 minus 25. And when I do that, that gives me 97.3 degrees. Okay, now to find sine B, since I know that this angle, let me erase some stuff there. This angle up here is 97.3 degrees. And remember, we did have that full fraction. Now I'm just going to use law of sines again. And I'm going to do sine of 25 over 1. That was my full fraction. And then sine of B, which is sine of 97.3 over little b. Cross multiply. So that gives me B times sine of 25 equals sine of 97.3. Divide both sides by sine of 25. And I get little b is approximately equal to, I have to do sine of 97.3, close your parentheses or hit enter, divided by sine of 25. That gives me 2.35 if I round. So that gives me 2.35. I'm going to go ahead and go 2.4 if we're rounding to the nearest tenth. Like I did for the angles, we'll just call it 2.4. All right, so there's the first triangle. So now we got to do the same thing for the second triangle. So to find angle B, we've got two of the angles, so I just have to take 180 and subtract 122.3 and then also subtract 25. That gives me 32.7 degrees. 32.7. Okay, and again, to find little b, we know this is side C and this is side A. I'm going to go ahead and use the original information that I was given, which was that full fraction of sine of 25. So it's sine of C, or 25, over 1. And then if we use b, it's sine of 32.7 over little b. Cross multiply, I get b times sine of 25 equals sine of 32.7. And again, divide both sides by sine of 25. So in my calculator, I do sine of 32.7, hit enter, close the parenthesis, divided by sine of 25. And that gives me approximately 1.3. So 1.3 for B. And there we go. So again, two triangles were possible, and we had to find all of that information for both of those triangles. So yes, it can be somewhat annoying when there's two triangles because it's basically two problems in one. All right, so let's take a look at this example. Okay, so it basically says, is there a second triangle? Okay, so we know, again, we know side, side, and angle. Okay, so since we have side, side, angle, yes, this could be ambiguous. Okay, I drew both triangles, so we can call this triangle 1. Let's call this one triangle 1 and call this one triangle 2. And we'll see if there is a second triangle. Okay, so let's start with triangle 1 on the left side. I know this is little a, this is little b, and this is little c. Okay, so again, we do have that full fraction of sine of 40 over 3. So there's my first part. I've got sine of 40 over 3. The only other piece of information that I know is this right here. So angle, or the side is 2. So that will allow me to find sine or angle C. So it's sine of C over 2. Go ahead and cross multiply. It's 3 times sine of C equals 2 times sine of 40. Divide both sides by 3. and it gives me sine of C equals, and let me plug that into my calculator, 2 times sine of 40, hit enter, divided by 3. That gives me 0.428 approximately. Okay, so again, I'm going to keep that number in my calculator. Don't round it to 0.429. Don't round it. Keep that number in your calculator. So what we have to do is we have to do inverse sine. So second sine, and then press second, and then the negative sign. That drops down the answer, and that gives me 25.4 degrees. So that gives me angle C is approximately 25.4 degrees. Okay, so in this triangle, angle C is 25.4 degrees. That's okay because I've got a 40 and a 25. That's about 65 degrees. We're good there. But remember, to find C prime in the other triangle, I have to do 180 minus that reference angle of 25.4 degrees. So when I type into my calculator 180 minus 25.4 degrees, that's approximately equal to 154.6 degrees. So if I plug in that 154.6 degrees, we have a problem, because if I add 40 and 154, that's 194. So that triangle is too big, right? All the angles have to add up. So in this case, I know that there is no second triangle. So the nice thing here is all I have to do is finish the first triangle. All right, so we know angle C. We can find angle B by just doing 180 minus 40 minus 25.4. So 180 minus 40 minus 25.4 gives me 114.6 degrees. So I know angle B is 114.6 degrees. So far I've got angle B, I've got angle C. So all I'm missing is little b. So again, I want to set up my full fraction, which was sine of 25 over 2. And that has to be equal to sine of 114.6, which is b, over little b. Okay, go ahead and cross multiply. So that gives me b times sine of 25 equals 2 times sine of 114.6. Divide by sine of 25. And we get little b is 2 times sine of 114.6. Hit enter, close your parentheses, divided by sine of 25. That gives me 4.3. All right, so then little b is 4.3. So now we have solved that complete triangle. And again, there was no second triangle. All right, so let's take a look at another one. All right, do we have a second triangle here? So far all we have is 75 degrees, and we have two sides. So yes, we have side-side angle. So yes, this could be ambiguous, so we do have to try for that second triangle. Okay, again, my full fraction here is sine of A over A. So this side is A. Straight across from B is B. We don't know anything about angle C or side C. So our first fraction is going to be sine of 75 over 6, and that's going to be equal to sine of angle B over side B in this case, which is 8. Again, I can't use C because I don't know anything about angle C or side C, so that won't give me anything. I'd have two missing pieces. So if I go ahead and cross multiply, that gives me 6 times sine of B equals 8 times sine of 75. Divide both sides by 6, and that gives me sine of B is equal to, let's see, 8 times sine of 75. Hit enter or close your parentheses. That gives me sine B is equal to 1.28. Okay, so right away, don't even waste your time. I see that sine is bigger than 1. So in this case, there is no triangle possible. Okay, so that is the one that you like to get because it is a heck of a lot quicker. All right, I want to do one more example. We're not going to solve the entire triangle. We're just going to see if a second triangle exists. So again, I do have side-side angle. So yes, I do have to try the ambiguous case. I know angle A and side A. Okay, so that's equal to side A, and this is C. So the first thing we're going to find here is sine of C. So I get sine of A over sine of 35 over 6 is equal to sine of C over 8. Again, do that quick cross multiply. I get 6 times sine of C equals 8 times sine of 35. Divide both sides by 6. So I get sine of C equals 8 times sine of 35. Hit enter, close your parentheses, divide by 6. And that gives me 0.76 approximately. So again, I have to go second sine and then second and then the negative sign. And that gives me an angle of 49.9 degrees. Okay, so in this triangle, angle C is going to be 49.9 degrees, which is good. I've got 35 and approximately 50, so that is well under 180. And then to find C prime, I'm going to go ahead and take that reference angle. So again, we know right now that gave us 49.9, so we need to find the other one over here. So we're going to go back from, back from 180. So we're going to subtract 49.9. So I get 180 minus 49.9. That gives me angle C prime is equal to 130.1. And if I put 130.1 in there, that's okay because I get 35 and 130. That only adds up to 165. So that leaves plenty of space. All those triangles have to add up to 180. So that still gives me an angle B of approximately 20 degrees. Okay, so again, this situation, you would have to solve both triangles. Okay, for time reasons, I'm not going to do that. I've done that in a couple other examples. All right, so let's take a look at one application problem. It says 2 meteorologists are 25 miles apart, located on an east-west road. Okay, so again, we know that we've got on our compass, north is up and down, east is to the right, south is down, and then west is to the left. So we know that horizontally on an east-west road, we've got 2 meteorologists. I'm going to call meteorologist A over here, meteorologist B over here, and I know this is 25 miles. All right, so it says the meteorologist at point A sights a tornado north 35 degrees east. Okay, so we talked about bearing before. Remember, we've got to draw that north-south line. We want to rotate. To the east, so it's north 38 east. So we're rotating to the east 35 degrees, and then there's the tornado. As you can see, I'm a really good artist up there. All right, so it says the meteorologist at point B sights the same tornado. So I'm going to draw that north-south line. North 53 degrees west. So again, he's going to rotate to the west, sees that tornado. So this angle right here is 53 degrees. Okay, so one of the things that we have to remember is that the north-south line as well as the east-west line are perpendicular. So we know that these two angles have to add up to 90, and so do those two angles. Okay, so that allows us to get inside that triangle. So on the left side, if I do 90, oops, that was 38 degrees, not 35. Sorry about that. If I do 90 minus 38, that gives me 52 degrees on the inside. The other angle was 53, so if I do 90 minus 53, that gives me 37 degrees inside there. All right, so then all we have to do is we have to find the distance from point A to the tornado. So we are looking for this piece of the triangle. All right, so I'm going to redraw the triangle without all the extra parts there. So we've got A, I'm going to call this point T up there for tornado, and point B, we've got 52 degrees, we've got 37 degrees, and we've got 25 miles. Okay, this is angle B, so opposite angle B is little b, and that's what we're looking for right there. Okay, so again, is this or could this be ambiguous? No, because we've got angle in a side, so it's not ambiguous, so we don't have to find two triangles. There's only going to be one solution here. Because we know this side down here, we've got to figure out this angle. So if I take 180 and I subtract 52 and 37, that gives me 91 degrees. So we're close to doing SOHCAHTOA, but unfortunately that's 91 degrees. So we have to do law of sines. Okay, so again, I do have a full fraction. I've got 91 degrees and 25. So I can do sine of 91 over 25. And since I'm looking for this guy over here, the distance from A to the tornado, I'm going to go ahead and use angle B and little b. Okay, so angle B is 37, so it's sine of 37 over little b. Cross multiply, I get B times sine of 91 equals 25 times sine of 35. Divide both sides by sine of 91. So to find the distance from point A to the tornado, we've got to do 25 times sine of 35. Hit enter, close your parentheses, divide by sine of 91, and we get approximately 14.34 miles. Okay, so it's about 14 miles away from person 1 to the tornado. That's all we got for today.